My goal is that this is the most fun you'll ever have learning about statistics, because it's really more about, and maybe this doesn't sound like fun either, management, using statistical methods to improve the way we manage performance measures, which hopefully means improving the way we improve our organization. So, but for anyone who's read Eric's book, the very last words in the book are actually a question. If we stopped wasting people's time, what would they do with it? I think to me this resonates with the lean notion of respect for people and not wasting people's time. So in the Lean Startup movement, there's a big focus on the questions around what do we measure? How do we know if we are on a path to success or not? In his upcoming book, The Startup Way, it says something here about the fact that your site, using an example of a vanity metric, that your site has seen an uptick in visitors doesn't mean that your product is more popular or that you're more successful. You could be doing all sorts of things to drive traffic to your website, but if it's not turning into leads and customers, who cares? But I would extend this thought and say, well, maybe we modify it a bit to say the fact that your site has seen an uptick in visitors doesn't mean your site is getting more visitors. You might say, well, wait a minute. If a number is higher than another number, clearly we have more visitors. And you might say, that's true. I went to my blog and pulled up monthly visitor data, and I can find an uptick from March to April of this past year. So I'm like, well, wait a minute. Clearly, that line is going up. Your blog has more visitors. Congratulations. But I think in organizations we do a lot of this. We look at two data points, and we either draw a faulty conclusion or we use it in a convenient way to prove a point we want to make. We step back and look at data over time and say, well, is my website really getting more visitors? I would look at this and say, well, if you were to draw a linear trend line, which can be a little statistically dubious if you're not careful, my site is actually getting fewer visitors over time. So how can that be true? Traffic is both going up and going down. You might call this Schrodinger's chart, if you will. Both of these things might be true. I'm glad some. Thank you for that. Thank you for laughing. So we ask, what do we measure? I think an important related question is, how do we manage these measures? We might choose the right measures, but we need to make sure we look at it the right way. So I taught a workshop on using these statistical methods to evaluate healthcare performance. A woman from the British National Health Service brought data, and in our discussion she said, I need a chart that shows we are improving. Well, I don't know if this is a good scientific path to go down. She said, well, I need to show that patient falls are 50% lower, because that's our government mandate. We need to show that level of performance. Like, well, we could look at the data and find two data points. If we want to do a before and after, look, falls fell from 30 a week to 8 a week. This might be a form of what Eric and the Lean Startup movement calls success theater. And we see this in organizations because of the pressure placed on us, or just our desire to make it look like things are better than they maybe really are. Her full chart, looking at that trend over time, looks a lot like my blog traffic data. It goes up and it goes down. But if we cherry pick any two data points out of this chart, there's this question of, are we painting a picture that tells the story we want to tell, or are we looking at what statisticians would call the voice of the process? So the voice of the customer is an important idea. A chart like this is the voice of the process. So are we willing to look honestly at what that process is doing? Are we making the right decisions about how that is performing? In Eric's book, new book, he talks about this idea of a commitment to truth. And I think for anybody who's trying to build a business or improve a business, whether it's a startup or a hospital, we should have a commitment to not either inadvertently or intentionally misusing data to tell the story that we want to tell. So as Eric said in his first book, energy invested in success theater is energy that could have been used to help build a sustainable business. I would extend that to say that success theater energy could have been used to improve a business. I want to share some examples, maybe help illustrate that. This question of how do we manage our measures? We want to be careful that the alternative to vanity metrics is something Eric calls an actionable metric. We want to make sure we choose the right metric, but I would suggest we want to make sure that these aren't overreaction metrics. So let me show you a scenario that illustrates something I've seen in many industries, large companies and small. So let's say we have a chart with some data. We have an initial data point. We have about 86 new user registrations. Management looks and says, well, we need that to be better. We want that to be higher. We're going to set a goal at 90. We need more new user registrations. So we look on the next day and we say, well, it looks like we had about 92. We'll label that data point green. It's better than the goal. We might praise the team and say, good job. We might pat ourselves on the back and say, see what happens? They didn't have a goal. Look how motivating this was. And then the next day, the number's a little bit lower. A manager, a vice president might send a memo off or scribble a note. Please explain. The next day, we see a performance gets better. We're back above the goal. We're like, oh, what a positive trend. We might celebrate. We might bring in beer and pizza. Performance drops. It falls again below the goal. And now as managers who think, well, see what happens when we try to get positive reinforcement? People slacked off. What's going on? This is unacceptable. We bring the hammer down on people. Performance gets better. We say, way to go. Performance drops. We start using this really loaded phrase of, we're going to hold people accountable. So when we look at this, and we kind of laugh and say, well, what's going on here, statistically speaking? That a lot of this is just noise in a system. As we see in the red bead experiment, the same process, the same system will sometimes generate different results, whether we like it or not. So one of the lessons here is to stop wasting time explaining noise in the data. One of the lessons here is that there is no root cause for this day-to-day variation. Doing a 5 whys analysis might very well be a waste of time. So there are a lot of great lessons from a book by a statistician, Don Wheeler. His book, Understanding Variation, which is a very short, readable book on statistics. Recommend this book highly. The lesson I've learned from Don Wheeler's work is this idea that while every data set contains noise, because there's always variation, some data sets may contain signals. So before you can detect a signal within a data set, you have to first filter out noise. So thankfully, there's a method for doing this. We don't have to guess. We can apply a little bit of math and use something called a process behavior chart. This is Don Wheeler's term. It's basically what Dr. Deming might have called an SPC chart, a statistical process control chart. So if we look at this chart of the new user registrations, we calculate an average, and we look and say, well, you don't need a PhD in statistics to realize about half your data points are above average and half are below average. And asking for an explanation of the below average data points, again, just might not be a good use of time. We calculate something called process behavior limits. These red lines that fall at approximately 74 and 104. And what this method shows us when we plot our data is that basically any data point, any single data point between 74 and 104 is most likely noise in the system. And when this is the case, asking what went wrong yesterday is not the path to improvement. So if we extend this chart, we use this on an ongoing basis. We've established our average, our process behavior limits. There's a number of rules, heuristics, that we can use to determine if we have a signal. One of those, the simplest rule, is any single data point that's above or below these process behavior limits. Statistically, the voice of the process is saying, that's unlikely to be random. We would call this a signal. This is worth investigating. If we're going to start asking why, this would be a good time to do it. So it's not just about this one metric. Think about an organization that has 20 metrics on their dashboard. 10 of them might be below average, 10 of them might be above. If you send everyone down the rat hole of investigating the 10 that are below average, you're wasting time that might be better spent investigating the 1 or 2 that have a meaningful signal. So this is a good signal. We would ask, why did we have an increase in the number of new user registrations so that we can hopefully learn from that? Did we make a change or did something happen? Can we capture that learning and continue the better performance? In the opposite direction, we might see a number like this, below the lower process limit, which is again a signal. This is a statistically significant drop in new user registrations, where again it would be appropriate and useful to ask why. Not for the daily up and down blips, but for this significant signal. So can we find a root cause? If performance dropped, and we can isolate the cause and eliminate that cause, performance might go back to where it had been. This is kind of the equivalent of firefighting. This doesn't necessarily improve the performance of the system. So I think this is an important question. Can we improve the system? So let's say we had this data, it dropped and it recovered. Let's say we have some sort of intervention. We're making some change to our marketing approach. We're using social media differently. We've changed the user registration form to remove some sort of barriers to registration. We can use this process behavior chart as a way of testing our hypothesis that this intervention will improve performance. So if data looks like this over time, we don't have one data point outside of those limits, but one of our other signals would be 8 consecutive data points above the previously established average. Again, this is statistically unlikely to be random variation. It's a signal that either something happened or it confirms the change that we made is actually an improvement. So in a situation like this, we can calculate new limits. We have a new higher average, and there's still going to be variation and noise, but now it's fluctuating around a higher band that's a little bit tighter. So the one good thing about a chart like this is that it allows us to predict future performance. Future performance is not always going to be 95, any more than we would always have 10 red beads in that paddle. But this gives us the expected range. So we can try, again, to improve the average or tighten variation by testing possible changes to our system. So one of the companies I'm involved in is a startup called KaiNexus, and we track metrics like this. And our CEO will often ask our director of marketing a question like this: why were leads down last month? And the honest answer usually is something like this. They were down. And talking with the director of marketing and asking her what happens when the CEO, well-intended, he's not beating her up verbally, he's just asking, why was it down? And she'd say, she'd go spend time looking for or cooking up an answer, what Don Wheeler calls writing fiction. Let's not waste time writing fiction. Coming up with some sort of plausible explanation for why the number was lower. If you watch CNBC or the Nightly Business Report, they're always trying to explain every up and down in the stock market, and there might not be really a reason, but as people, we tend to want a reason. So when we understand statistical thinking like this, as I've coached the team at KaiNexus, instead of wasting time cooking up an answer, our director of marketing can spend time doing things that would increase the number of leads. An hour digging into data and cooking up an answer might be better spent writing a new blog post and sharing that in social media that might attract more people to our website who are going to convert into leads. And then it comes back to a question of how are we using our time? So instead of just reacting to every up and down, I've helped the team at KaiNexus create charts like this. And when we look at, let's say, the number of tier 1 leads over time, about half the time that number goes up and about half the time it goes down. That's to be expected. So when we calculate an average number of leads, when we calculate our process behavior limits, the process is telling us that basically anything between 0 and 20 leads is to be expected. If we were to see a significant shift in the number of leads, that might be worth reacting to. Asking about every up and down, not so much. So we want to make sure we're not wasting the opportunity to learn and improve. Let's say the data over time looks like this. This is a different form of signal. Well, actually, it's another example of having 8 consecutive data points above the old average. This is worth digging into. This is worth asking why. Because if we don't understand why the number of leads went up, I think the risk is the number of leads might fall back down. So this is really about understanding our system. So if we end up in a good situation where the number of leads, instead of being flat and fluctuating around a stable average, we sometimes have situations where it's linearly increasing, but guess what? There's still variation around that linear trend. And we can calculate, it's a little bit more complicated to do, calculate control limits that go up like this.
So, I'm sorry.
A different form of noise.
Is
Yes?
this before or after you've tried to do some form of root cause analysis that you mentioned on the previous slide?
So, well, in a situation like this, I wouldn't call it this root cause analysis. This is more a matter of understanding your system. There's not a single root cause we're looking for. We might brainstorm what are all the different things we could do to try to increase the number of leads over time, to make some sort of change to our system. So let's say we made a change and we see performance shifting like this. We say it's no longer just stable and fluctuating, it's increasing and fluctuating, which would be a different way of confirming our hypothesis that we've made a change, we hope things were going to get better. The other thing a chart like this can do is help you detect, hey, something changed. It might not have been an intentional intervention that somebody was testing. It could be that you discover it appears something changed and we should go and investigate why. So there might be more, you might call this a root cause. What was it in the system that made performance start going up? But one of the keys I think here is to recognize we have those bands and to stop overreacting to any point that's below that increasing gray linear trend.
So at some point is some, because I have some familiarity with Wheeler's book. And
Oh, great.
I've heard stuff called Wheeler's charts before, and maybe I'm misremembering, but I remember stuff that tries to go towards, how can you determine what might be common cause versus so-called special cause, or assignable versus unassignable. Is this?
Yeah, so I'll touch on
that.
I'll touch on that toward the end of the talk. Common cause variation. These are the variables that are present in our system every single day that lead to this just kind of up and down. What we call a special cause might be something unique that happened that either led to a dramatic drop, like we saw here. That could be a special cause that we isolate and eliminate. It could be that our website was down and that problem is fixed and so performance goes back to where it had been.
Well, special cause could also just be noise, right? We don't know. It doesn't necessarily happen frequently enough, or...
Well, I would equate a special cause to a signal and common cause to that noise in the data.
But in both cases, those are assignable cause as opposed to unassignable cause.
Right. I would call a special cause and assignable cause. We're going to do that analysis and investigation to figure out, can we determine what led to that signal, that statistically significant shift. So I think part of the answer to Eric's question at the end of the book came a couple paragraphs earlier. If we stopped wasting people's time, what would they do with it? We would achieve speed by bypassing the excess work that doesn't lead to learning. So I think all of this overreactive investigation into all of our ups and downs in the data, are, I think, fit that definition of excess work that doesn't lead to learning. If we're not learning, that's not leading to improvement. And the idea is that we can improve more if we overreact less. If we're reacting to signals instead of overreacting to all of the noise, we better focus and prioritize our efforts that we put into better understanding and improving the system.